And by now, I hope you're not bored yet because we have a lot to discuss. So if you want to grab any energy drinks or coffee, then you can please do that. And if you need to understand IAM, you need to think of IAM by dividing it into two parts. The first one is identity. And the second one is access management. And each of these has features that make it a complete solution for user provisioning or access provisioning. And when it comes to identity, we need to talk about users, user groups, roles, tagging IAM resources, and temporary security credentials. And if you read these topics, they are inclined towards the identity aspect of the resource. And on the other hand, we have access management. So here we need to talk about policies and permissions, managing IAM policies, understanding policies, and permission required. Now let's start with identity. As we have already discussed users and user groups, let's move on to what is an IAM role. In life, we have used this word role many times, most often when it comes to fulfilling certain responsibilities. You might also laugh when I say that in school I acted in a play, when I performed the role of a youth activist protesting for the rights of young India. Yes, I did that, and I'm really proud of that. So I performed a role there. In my first job, my role was to write scripts for an application as a software training. So I had a role there, and my responsibility was defined by what my role was. Similarly, let's suppose this is you. And you might be working in construction or working for a mobile app company or a restaurant or a food chain or a fast food chain. These are the type of industries where you might be working. But you will have a certain role that will be defined as your responsibilities in the organization. If you're working in construction, you might be having a role of a site manager. If you're working in a mobile application, your role might be as of a developer. Now, I'm asking you, what is your role at the place that you're working right now? Do you have an answer for that? Yes, you will be having it. Imagine that you're working at all these 4 places. But when you go to the construction site, you assume the role of the site manager. And when you go to the mobile application company, you assume the role of a developer. Similarly, it goes with the other 2 jobs as well. You have to remember this line. When you have a role, you need to assume the role, which will give you the permissions to perform your job. Now let's see what is an IAM role. An IAM role is an IAM identity that you can create in your AWS account that has specific permissions. If you want to understand the English meaning of identity, identity is the fact of being who or what a person or thing is. That's his or her identity. In IAM, we have permission policies that grant permissions for an identity to perform certain operations. Like if we see here, we have Amazon EC2 full access. This policy grants permissions that allow full access to Amazon EC2 resources. You can create EC2 instances, you can terminate them, you can restart them, you can shut down them. It depends on you on what operations that you want to perform. But with Amazon EC2 full access, you get all the access that you want. And it's up to you on what operations that you want to perform. Similarly, we have AWS managed policies like Amazon RDS full access and AWS health full access. And these policies, you should always remember, are only attached to the IAM user, like you or your team members. But what if you want to have permissions for services and users themselves to perform certain operations? And that's where we create roles. For example, I can create a role with the following policies by the name of EC2 or AWS EC2 role that has all these 3 policies attached to it. And the interesting part is this role can be attached to the users like you and also to the services like EC2 or Lambda, which allows them to perform operations on services that they want or that you want. And the users that you see here can be from your account or it can also be from another account. But that depends on how the role is being defined. I hope you got the point here. And you might ask me, why does a Lambda function need an EC2 role? Let's suppose you're working on a script which creates automatically a EC2 instance. By default, if you try to create a EC2 instance using a script in Lambda, it will not work because it does not have sufficient permissions to use the EC2 resources. So we can create a role and attach a policy for EC2 into that role, and the same role can be attached to the Lambda function. With that, it will have sufficient permissions to create or manage the EC2 instances or resources that belong to EC2. But there are certain rules regarding permissions that we need to understand. An IAM identity that you can create in your account has a specific permission. And here we are going to see how the roles can be used and by whom. And roles can be used by the following. First one is an IAM user in the same account as the role. So if you are a user in the same account, you can create a role and attach that role to your user. And with that, you get permissions to work on the individual resources that you want. Next is an IAM user in a different account than the role. So let's suppose you have a user that is working on a different account and wants to access resources that are present in your account. So you can create a role for that. Here we can create a role with assume role policy and define permissions for the services that you want a user from another account to make use of in your account. Next is a very important thing, a web service offered by AWS such as Elastic Compute Cloud or EC2, as I already mentioned before. So if you have a Lambda function and you want to create EC2 instances using Lambda, by default Lambda does not have permissions to create EC2 instances. So you can create a role and attach that role to Lambda function. Similar thing goes when you want to update a S3 bucket. You can create a role for your EC2 resource that has permissions to update the S3 bucket and attach it to your EC2 instance. And that way it can also update the S3 bucket or use S3 resources. Lastly, an external user authenticated by an external identity provider service that is compatible with SAML 2.0 or OpenID Connect or a custom identity broker. So this is for the external users who are authenticated by a separate identity provider. And that brings us to the next topic. What are temporary credentials? When you're working in an organization, the authentication mechanism used is most probably federated login. When you join a new company, the first thing that the HR does or asks the IT team is that they should create your username and login, and that is how you will log into your designated work laptop or desktop. And most of the companies use an identity federation service like Active Directory Federated Services, and you become a part of the organization. And you become the federated user. Now there might be an AWS resource that you want to use, and you will tell me, let's create an IAM user in my name and give me the credentials. But you need to understand that it's not necessarily required to create an IAM user with your name for you to make use of the AWS services. Yes, that's right. You might say, what are you even saying? Yes, let me explain this. Keep watching. So you are a part of the federated identity service, and this is the AWS account and the resources that you want to use. You will ask me, how will I access them without having an IAM user? And that's where we need a service that can help us with a temporary login to access the services, which is Security Token Service provided by AWS, or what we also call popularly as AWS STS. Now let's understand how this works. As a federated user, we initiate the authentication to the ADFS, that is Active Directory Federated Service, using the SSO URL. That's the first step. You initiate the authentication request using SSO, and that's the first step. Second, if you have used SSO before, you know SSO uses security assertion and validates the credentials and sends an acknowledgement with or without a URL redirection, and that's what happens in the step 2. This security assertion, or what we call as SAML assertion, is being sent to the AWS STS service, and we assume a role using assume role with SAML API. One thing that you need to remember here is the temporary security credentials created by assume role with SAML can be used to make API calls to any AWS service with the following exception. You cannot call AWS STS get federated token or get session token APIs. That's the whole point, isn't it? Because it will defeat the whole purpose of the session-based login. It's like keeping the cat in charge of the fish. So you cannot create get federated token or get session token API operations when you're working with STS. Next, the STS service returns a set of temporary security credentials. for the users who have been authenticated via a SAML authentication response, like we did just now. And this operation here provides a mechanism for tying an enterprise identity store or directory role to the role-based AWS access without user-specific credentials or configuration. And that is why you get the access, but you don't need to be an IAM user. Lastly, after you have received the temporary credentials, the user will then have federated access to the AWS services. And this is what happens in most of the companies right now. Nobody is wasting time to create IAM users because every day or month, people join or leave organizations. They won't keep on adding or removing users. That's the job of the IT team. That will be managed by the IT team, and the rest is integrated using SAML, SSO, and identity provider services. And now it will be easier for us to understand the statement written above. Identity federation is a system of trust between two parties for the purpose of authenticating users and conveying the information needed to authorize their access to resources. So it is a system of trust between two parties for the purpose, and the purpose is authentication of users and conveying the information needed to authorize their access to the resources. So based on the federated user or the federated login that you have, you create an assertion, and based on that assertion, you send the request to the STS, security token service, and after the handshake is done, you send the temporary security credentials back to the federated user, and based on that trust that has been formed, he or she is allowed access to the AWS resources. And that is how we make use of the temporary security credentials to make use of the AWS resources that we have. And that also depends on if the permissions are allowed for that particular user or the user group or that login session. And that is dependent on the session policies. But don't worry about these details right now. Let's just see this example and consume the data, and let's move forward. Here you must focus on the term use STS to provide trusted users the access. We are providing access to the trusted users because we have a mechanism to validate who is a trusted user. And now what AWS STS has to do is to provide the user with a temporary credential to access the services, considering the fact that a role is already defined for that access. And that's a simple thing to do, but it has a lot of details involved in that. Now let's see what are its differences to long-term credentials. The first point that we have here is they can be configured to last for anywhere from a few minutes to several hours. I think this is the best way to implement a secure environment, but there are other good ways. But this is a very good way because you don't have to worry about a credential expiry. Secondly, after the credentials expire, AWS no longer recognizes them or allows any kind of access from API request made with them. That's also awesome. The third one that we have here is temporary security credentials are not stored with the user, but are generated dynamically and provided to the user when requested. That's the best thing, isn't it? You request for a temporary security credential, you get them. There is no need to store the credentials with the user. Now let's talk about the advantages of using temporary credentials. I think we have already discussed a lot about the advantages, but still. So you don't have to distribute or embed long-term AWS security credentials with an application. That's a good thing because that will be much easier to manage and secure as well. Second, you can provide access to your AWS resources to users without having to define an IAM identity for them. That's right. You don't need to create the IAM user, but still you can provide access to the AWS resources. And last but not the least, the temporary security credentials have a limited lifetime. So they have a limited lifetime. So you don't have to rotate them or explicitly revoke them when they are no longer needed. If the credentials are not long-term, so you don't have to rotate them or think about how you can encrypt them or store them or explicitly revoke them when they are no longer needed. So I hope you understand the point of having IAM users and federated users in terms of using AWS resources. We just discussed the use case where we made use of the identity federated service and its integration with AWS STS to allow access for the trusted users to execute operations on AWS resources with obviously using temporary credentials. As you can see, for identity federation, we have enterprise identity federation like we used for ADFS or like we discussed for ADFS or IBM. Next, we have web identity federation. For this one, what AWS tells us is that With the Web Identity Federation, you don't need to create custom login or custom sign-in code or manage your own user identities. Instead, users of your app can sign in using a well-known external identity provider, such as login with Amazon, or you can log in with Facebook, Google, or any other OpenID Connect. And at last, we have custom federation broker and federation using SAML 2.0. Here what AWS tells is that AWS supports identity federation with SAML 2.0. So if you're using SAML 2.0 already, AWS supports identity federation with SAML 2.0, which is an XML based protocol that uses security tokens containing assertions that help in authentication. And this feature enables federated sign-in or single sign-in, so users can log into the AWS Management Console or call the AWS API operations without you having to create an IAM user for everyone in your organization, which we already discussed in the previous example. So this is a very good thing. Next up, we have roles for AWS account or cross-account access. For this, we can define user identities in one account and use those identities to access AWS resources in another account that belong to your organization. Next is roles for Amazon EC2. This can help you in the use case if your application or if you run your application on Amazon EC2 instances and those instances need access to Amazon or AWS resources. You can provide temporary security credentials to your instances when you launch them. And this also can be done by creating roles. And last one that we have here is AWS services itself. And you can use temporary security credentials to access most AWS services. There is a list of service that you can create the roles for. And this list I'll provide, or the link that I have, I'll provide it in the description below so that you can check out all the services that we have that you can create roles for and make use of them. Now that we have seen how we control access with IAM and roles, let's check out how we can actually manage it. And that's where we are going to discuss about access management. We already discussed we can do a lot with IAM users and roles and give them permissions to actually perform operations on AWS resources. But the biggest question that arises here is, how do we actually do that using IAM? Yes, we can do that by using IAM policies. Let's read this. You can manage access in AWS by creating policies and attaching them to IAM identities or AWS resources. You must understand that policies in AWS are nothing but JSON documents that are attached to an identity or resource, which helps to define the permission. I have repeated this 3 times now for you to understand. For example, if you create an IAM user and that user wants to create an EC2 instance, by default, the permissions will be 0 or denied. Until and unless you attach an AWS EC2 policy to that user, he or she will not be able to perform the desired operation. Remember that. Now let's check how does a policy look like. Here you can see we have optional top level element. Then we add statements as per our requirement. We can also add an optional policy-wide information at the top of the document and one or more individual statements. We'll discuss the example, don't worry, I'm just giving you an overview of how the policy looks like. And the most important thing to remember here is that each statement includes information about a single permission. If a policy includes multiple statements, like we have here statement A, B, and C, AWS applies a logical OR across the statement when they are evaluating them. If multiple policies apply to a request, so if suppose this is the policy, there can be multiple policies like this and which are applied to a single request. In that case also, AWS applies a logical OR across all of those policies when evaluating them. Let's check this statement by expanding it. Each statement information is contained within a series of elements like SID, that is statement ID, effect, principle, action, resource, and condition block, which is also called as the PARC model. If you see PARC, you have to remember it in a way. You have the principle, you have the action, you have the resource, you have the condition block. It's not that you will be using all these 3 entities every time in a statement or a policy, but you have to remember when you're talking about a JSON policy or IAM policy, you always think of the PARC model. It's easy to remember. PARC, that is principle, action, resource, and the condition block. We will discuss each of these terms individually. For now, just think about the PARC model. I know I haven't explained these terms in detail, but don't worry, we will discuss in depth, so keep watching. As I've already told you, each statement includes information about a single permission. So each statement that you have here will be having information about a single permission, whether it is allow or deny. If a policy includes multiple statements, as I already told you, like there can be multiple statements, then AWS applies a logical OR across all the statements when applying or evaluating them. So statement A or statement B or statement C, the logical OR. If multiple policies also apply to a request, AWS applies a logical OR across all of those policies when evaluating them. Similar to the statements, if there are multiple statements, we can have multiple policies also attached to a request. That time also AWS applies a logical OR across all those policies when it is evaluating them. But before moving forward, we need to watch this segment again. Do you now understand who can access what? Who is the identity? Can access is by using your IAM policies. What is the AWS resources within your organization?